Section 26.6, lenses. So lenses are usually pieces of glass like prisms that refract light in such a way that you're able to form an image of the source. And we'll see two different types of lenses. One will be the converging lens, and for that, paraxial rays, so light rays that are close to the principal axis and parallel to it, converge to a focal point. So if you have you could imagine two prisms, and we know prisms in air can bend light downward. So if we stack two prisms on each other, they bend the light towards itself. And we could specially shape a lens so that any of those light rays that are close to the principal axis all actually converge at a single point. They're able to focus at that focal point. And the distance from the lens is said to be the focal length of the lens, noted with that lowercase f. So this is our converging lens. The other type of lens we have is a diverging lens, which is similar to if we inverted two prisms so that they deflected the light rays away from the principal axis. The diverging lens is carefully shaped, though, so that the rays that are parallel to the principal axis all appear to originate from a single point, the focal point. Notice this is on the left side. Because the diverging lens makes the rays spread out more, it does not produce a real image. It's only a virtual image that appears to be at the focal point, which is again at the focal length f. So these are our two basic types of lenses, converging and diverging. And there are some different shapes that you can have with these converging lenses versus diverging lenses. One thing that's a little bit confusing is that converging lenses are made with convex shaped pieces of glass. Our convex mirrors behaved much more like our diverging lenses. Similarly, diverging lenses are made with concave shaped pieces of glass, but our concave mirrors behaved much more like converging lenses. So it seems a little backwards, and because of that, our textbook primarily refers to them as converging lenses and diverging lenses. And if you just keep it that way, they're a lot easier to keep straight. So telling you if the light is going to converge as it passes through the lens, or if the lens is going to spread out the light so it doesn't converge quite as quickly. I want to jump into section 26.7, the formation of images by lenses, to take a look at drawing ray diagrams for converging lenses and for diverging lenses. So first, for converging lenses, let's start there. And I already created something to help me out with this. So we have a principal axis drawn, and I also drew in the lens placement in the center. I could sketch out how the converging lens looks like so in blue, but that's just really to help me remember what it does. I'm going to stop the share so this is a little more apparent, but hopefully you can flip back and forth as necessary. Okay, so now you can see the whiteboard a little more clearly. There I have my lens. I drew in the blue just as a guide. I'm really going to draw it all the way to the black line. That's a much more reliable line. I also need to add in the focal point for the lens. And so for this one, I chose a focal length of 4 inches. I have one over here that we could also measure out. And it would be exactly 4 inches. Now, the focal length might not be 4 inches. Maybe it's actually 8 meters. But I could represent that 8 meters with 4 inches so that each inch on my drawing represents 2 meters in real life. So I drew in both of those, and then I could draw in my object. I'm going to do my object actually at a point that happens to be 2 times the focal length. Okay, so there is my object. And so then we have 3 principal light rays. There are many more light rays that would fill in, but these are the three that we're going to focus on. And they're very similar to what we had with mirrors. So that's awesome. So the first ray, just as with mirrors, is going to go parallel to the principal axis until it reaches the lens. So try to line this up as parallel as possible. There we go. Now the difference is because this isn't a mirror, this isn't going to reflect off the lens through the focal point, but it's actually going to travel on through the lens and go through the focal point on the other side. So I'm going to line up the top of the ray with this focal point F. Try to carry that on a bit further beyond. So that is my first ray. My second ray does exactly the opposite. It first passes through the focal length on the way to the lens and then travels parallel to the axis. So I'm first going to line up the top of the object, the focal point on the left side, and my ruler all the way to the lens itself. So that's 2, and once it reaches the lens, it then travels parallel to the lens, to the principal axis, perpendicular to the lens. All right, so there we have ray 2 filling in, and those 2 rays are enough that we could locate our image right at that intersection point, but we do have a third ray, and this one's a good one to fill in because it's not too bad to draw. So for this one, we just draw it from the top of the object through the center of the lens, right where that lens intersects with the principal axis. So this one, my little ruler is unfortunately not long enough to draw. I'm going to have to do it in 2 segments. Take it as far as I can. That's looking pretty good so far. Continuing this on, trying not to cheat it, just trying to line up with what's there. It's a pretty good line. All right, and so that is my third ray, going right through the middle, and we have a pretty good agreement where all 3 of them are intersecting right in this region. So I would say that our image is going to be right somewhere around there. Perhaps a little taller, could be a little to the left or to the right. But there we have the converging lens and how we draw the ray diagram. So I'm sharing once more so we can see these are the 3 different rays that I demonstrated how to draw. And the converging lens will always follow this pattern, even with some different scenarios, which we'll see in our next video. The diverging lens is a little trickier to draw. So for the diverging lens, and I'll demonstrate this one too in just a moment, ray 1 is going to appear to come from the focal length on the left, and ray 2 is going to head towards the focal length on the right. So it's like we just switched the focal points for the same rules. Ray 3 is still the same though. That one's nice and similar. So coming back to my picture, my diverging lens, I could fill in a frame just to remind myself that it is diverging. Right where it's wider on the top and the bottom. And for this one, let's see, at my ruler, I'm going to do a focal length that is represented by 5 inches, so a little bit bigger. And I want that on both sides. I have my other focal length, and I'll even note where it is 2 times the focal length, just because that's a handy reference, especially with converging lenses, not as crucial for diverging. But once again, I'll draw my object at about the same point just for comparison, because that's pretty instructive. And even drawing the object with a ruler can help you keep it more upright. Right, there we have my object. And now we can go through the 3 different rays. So as described, first ray is going to start out parallel to the principal axis as before. So that looks fairly level. One, and then as mentioned, it's going to appear to come from the focal point on the left. I'm going to do dots as though it's coming from the focal point, but the light itself is actually passing through beyond, and it is diverging. My lens would actually have to be a little bit taller than this, but that's okay. We're still doing just fine. So ray 2 is going to head towards the focal point way over here. So this one's going to be a little bit hard to do with my small ruler. My picture's a little bit big for the device that I have. But I'll try to eyeball it as best I can. So trying to line up the top of the object with the focal point over here. See, it's headed right towards that focal point. But it's not going to make it to that focal point. Instead, it's going to refract parallel to the principal axis on the other side. All right. And these 2 should be enough to locate my image, but the key is we're going to actually be looking at this from the right side. You can always imagine that you have an observer here who's looking, right, there's their eyelash, looking at this. And so what the observer would see is, we think that light travels in a straight line. So we'd see the light rays continuing back from ray 1. We wouldn't see it refract through. Similarly with ray 2, what we would actually observe from this right side, so we'd see the light ray coming back parallel to the axis. And I should have used my ruler there. But that tells me that my image is probably going to be about here, not at this upper one with the initial ray from ray 2. It's always the offshoot of the refracted ray. Okay, let's get my ray 3 so that I have a deciding factor. And this one, as before, is the simplest to draw because it's just a straight line. So from the top of the object down to where the lens meets the principal axis. Looks like it's about there. Just continue it on down below. All right. And so ray 3 just continues on in that straight line, and it gives us a pretty good intersection with what we're already seeing. That all 3 rays are intersecting around this point. So that is where my image would be. Okay, so that takes us through drawing ray diagrams for converging lens and for diverging lens. This is a good skill to be able to do to scale because you can actually solve for different parameters, right? So I can solve for my image distance, and I can see that it is an image distance of about -3 inches, which I could convert to whatever scaling factor is necessary to get the end result. So I'll share the screen once more so you have it at the end there to be able to see. I included a couple of links here in the slides. They're also on Canvas of some ray diagram simulations that can help you with visualizing how to draw the different rays. So I'd encourage you to check that out. You can also ask questions, and I'm happy to help.